Things started here. We're ready to go. Thank you for being here. I'm Dave Cedarberg. I'm the outreach coordinator for physics and astronomy at Purdue. And I have with me one of my star students, a phys-astro student, Alan. Alan, say a few words.
Hi, I'm Alan. I'm a junior in physics and astronomy this year. And so
with that, Alan, I'm going to turn it over to you and say, let's just dive in and show them how the lesson works.
And so let's just get right into it here. So with this activity, the first thing that students are going to need to do is blow up a balloon, and this is going to represent the sun. So as you can see here, these kids are holding up a ruler to the sun to try and get the diameter, and that's one way to do it. That is perfectly fine, but it might be a little inaccurate. And so, although it's quick, we have also in the lab provided a more accurate way to do this, and I will demonstrate that now. And so I'm going to stop share. All right, and so when they blow up this balloon here, should be about not too big, because we'll run into problems later, as we'll see. But we've provided these strings, and so the strings so that you can wrap it around the widest part of the balloon. Have the kids use a marker to mark on the string where that is, and then you can use a meter stick or a yardstick to get the length there. Obviously, we've measured the circumference of the balloon here, and so this can be nicely tied into a discussion of circles and the relationship between the diameter and the circumference of a circle, and how that's and the importance of pi, I guess, in that.
Alan, I'd also throw in that it's a little awkward with one set of hands when you have kids working in groups. It's a lot easier to do that with.
Yeah, absolutely. Have one person hold the balloon, another person do the string, and another person can mark with the marker. After we've done the balloon, we can start to scale the rest of the solar system, because now we have our sun, and it kind of sets the scale. And so we have these two data tables in the lab. The one on the left is for the sizes of the planets, and the one on the right is for the orbital radii of the planets. They're in different locations in the lab. The one on the left is in the worksheets. The one on the right is separate. But when we go in to get the scale measurements, it's good to do those together. And so what we use to get the scale measurements is this, let's see, Exploratorium website. Okay, so the Exploratorium, this is a nice solar system calculator, I guess. And so you can go down here, and we have a sun, and whether you measured it in inches or millimeters, probably inches, but you can put in a diameter of the sun, and let's say it was 10 inches. And then the Exploratorium website here, this calculator, will give you scaled measurements of all the rest of the planets in the solar system. So as you can see here, we're going to want to use millimeters for the body diameter. Here, that's the sizes of the planets. Because if we used inches, it would just be way too small for them to be able to measure later. So if we use millimeters, you can see that these smaller planets are still very small, but the larger planets get a little larger. And so that's why it's important to have a big enough sun, one that's not too small, because otherwise you won't be able to make the scaled planets. Over here we have the scaled orbital radius. And here we'll use feet So this first column, the feet column. And here, the close planets are not too far, 34 feet, 64 feet. This was for a 10-inch diameter balloon. But as you can see, as we get out to Neptune here, we're at 2,500 feet, which is very far. Pluto here is more than half a mile. And so there, it's important not to have the sun be too big, because you're just going to get distances that are way too far, and eventually we're going to need to actually be able to walk these distances. And so I would say that before doing this, it's important to figure out how much space you're going to have for when you go outside to walk off the distances, and figure out maybe what size sun will work best for you. Because if you only have a certain amount of space, then you can tell the students, well, make sure your sun is, this size, so that, you're able to get farther out. And some of these distances are so far that, probably won't make it to Neptune at all.
Alan, before
Yes.
you leave that slide, scroll down just a little bit and show folks, if your students want to know how close the nearest star is, I mean, Alpha Centauri on this scale is 4,000 miles. So, I mean, it's this is an incredible website to really get an idea of how tiny we really are.
They'll use the Exploratorium to find the, here in millimeters, the scaled planet sizes, and this first column here, the scaled orbital radius to the nearest foot. And so here's an example of after making all these planets. It's got about a 10-inch sun, and you can see how Mercury is tiny here. Jupiter's big, and we provided this sheet and they can tape the planets that they make to this page to just kind of be able to compare them all side by side and appreciate how small some of the planets like the Earth and Venus are compared to some of the other ones like Jupiter, and especially compared to their sun, which was this balloon. And so I think another interesting thing maybe to connect this activity to at this part when they're making the planets is an accretion model of the solar system. And so I think it's neat how, if they're building the planets, they might be, tearing pieces off to get the right size, putting pieces together. And that's similar to how some of the planets in the solar system were actually formed, with smaller bodies, the solar system accreting, colliding to make planetesimals and eventually the larger planets that we have now. And so it's kind of a similar process of them actually building the planets. And so now, finally, an answer to that, to your question from before, is walking the distances. And so how we do this is, it's maybe good to set up ahead of time, or the students could do this as well. Use a tape measure or meter sticks or count tiles in the hallway to mark off 50 feet. And then have each student walk at kind of a, a walking pace, a leisurely pace. We don't want them to walk toe to toe or take huge steps either, but just to walk at a normal pace and get a sense for how many steps 50 feet is at their own walking pace. I think in the lab, there's space provided for each student to do this 3 times and then take an average. They'll have gotten the orbital radii here to the nearest foot, and after they measure how many of their steps is 50 feet, they can calculate how many steps it takes to get to that that planet. And so if Venus was about 50 feet, then they would know how many steps that is and do that calculation for each of the planets. Now, because when we go outside and walk this off, you don't want to start from the sun every time. You want to just be able to go from one planet to the next. This last column here is to calculate the number of steps between the planets. And so you just take each of the values in this column and subtract it from the one before. So Venus minus Mercury would give you the number of steps to the next planet here.
Would you mind holding up the sheet that you made with the Play-DOH planets one more time?
Sure.
Just looking at the numbers that you had, I wanted to just see how you scaled it again.
There we go. That's not left, right, reversed for you, is it? Or is it? Okay, it is for me, so I just wasn't sure. Yeah, so I think this was about a 10.2 inch sun. Gives you less than a millimeter for Mercury, which is pretty small.
Thank you. That's perfect. That's helpful.
And I think if you have materials, we provided one tub of Play-Doh for each group, and that should be more than enough to make all the planets. Okay. And so finally, it's time to go outside, which is also always a fun thing to do in school, to be able to go outside. Like I said before, it's important to find enough space ahead of time. I mean, the one in this picture, the sun here, goes all the way down to a street corner that you can't even see in the distance. And so, you kind of want a large straight area, and it's nice to maybe find out how much space you have ahead of time so that you can adjust things a little bit to make everything fit well. When you go outside, when we do it, we usually have multiple paths with like a map marked out. So the kids aren't all in one spot and running into each other. But if you're limited with space, it would be easy to just do them parallel as well. At this point, it might be important to get extra supervision, especially if students are going in different directions, just because they might be getting pretty far away. Now, when walking from one planet to the next, it's nice for all the students to walk this distance, right? They all found their own 50 steps, their own distance between the planets, and so they can all walk at once, and they'll wind up in different spots, and that's another look at measurement uncertainty, and you can pick then kind of an average spot based on all the positions that they end up in. Students might not get to the planets at the end, and that's okay because they're really far away. And so probably won't be walking a mile to to get to Pluto. But definitely by the time they get to the end, they'll be able to look back towards the sun and you won't even be able to see it. And so by doing this, they can really get an appreciation for the distances between the planets, especially if they think back to the planets that they made, the sizes that those planets were, right? Because this distance scale is the same with the same sun as the planet scale. And so, the planets were tiny, but these distances are very large here. And so that wraps up the doing of this activity. If anyone has any other questions about going outside before we turn it over to Dave for a little bit. Dave, it's all you.
So when I've done this activity probably 10 times, And when we take kids outside, first of all, Alan's right. You got to walk this off ahead of time because, you know, I think the first time I tried it, I thought, well, this will be far enough. And it was not. And so I go out, you know, ahead of time and pace it off. And, you know, around campus, it's pretty easy because we have a lot of open space. I usually draw a map and I usually have one group go this way, one group go that way. I have an advantage that you don't have, and that is I have plenty of volunteers. So when I do this and I go outside with maybe 30 kids, I've got 10 volunteers to volunteer for every group. I'm worried about safety. I want to make sure that you know, nobody gets stumbles, falls, gets hit by a vehicle or anything. So that said, I think, you know, you could rely on parents. I've done this with grandparents. Grandparents love to do this kind of stuff. You know, parents work, grandparents don't. So you can use those resources. If you're doing this with younger kids, you could probably get kids from the local physics teacher to come and help out. I mean, it's a great service project. I do want to just say that, you know, Alan's got some comments later from some of the kids, but as many times as I've done this, you set up the sun and you walk 30 feet to Mars and another 30 feet to, not Mars, to Mercury, another 30 or 40 feet to Venus, and another 40 feet to Earth. And then, you know, where's Jupiter? So you got like 30, 30, 40, and Jupiter is 200 feet away. I mean, it's absolutely amazing. It's mind-boggling to think that Jupiter is that much further from the Earth. Anyway, I just want to say something about assessment. We've got I put a couple of assessments in the Google Drive that you have access to. You know, there are multiple ways to assess. I like to know in advance. We have a pre-assessment and a post-assessment. They're the same. But when, for example, on this slide, in the first row in A, the kids are going to draw the relative sizes. I mean, they have some preconceived ideas, and I want to know what their mental model is in their mind before we actually teach this lesson. And, you know, on the scale line on the bottom, kids will, you know, evenly space the planets. Whatever they do, they're going to be wrong. You can be guaranteed. So it gives me an insight into what kids are coming into instruction with. And so I like to use drawing. I like to use recognizing patterns, anomalies, you know, something that makes them think a little bit, a little more deeply. We've learned a few things. Making the clay models, as Alan pointed out, sometimes kids get a little carried away. I'm happy to provide different, you know, I take one little thing of Play-Doh and chop it into 6 pieces, and, you know, every group gets that color and every group gets a second. So I can give them different colors. If that's too much, give them one thing of Play-Doh and let them make their planets all the same color. The point is, they will spend half an hour making these planets, and they don't need to. It can be quick and dirty. Keep after them. You know, kids, you got 3 minutes left. Otherwise, you're going to just take way too much time. When they're doing the stepping in the hallway, we've tried it outside, we've tried it inside. I think it works better to do the steps inside before you go outside. That way they've got their, they can fill in their table, how many steps between planets. All the figuring out is done before they go out. In fact, I let them take out that one sheet, the sheet that Alan showed, the 2 tables side by side. They can take that outside on a clipboard, or not, just take it outside to refer to when they step off the planets. And, you know, we've tried this with, they go to Mercury and the kid stands at Mercury. I like to have a picture of, you know, kids standing there so we can see them from a distance. It doesn't work, as you might guess, to have a kid standing at Mercury while the other kids go on to the other planets. So every kid steps off their paces so they know how long they're going to go between planets. When they're in a group, you've got, you know, 4 kids in a group. They can agree and disagree. You know, are we there yet? Well, this is my count. What's your count? And so they can negotiate that a little bit. Then let's see. No, I just think let's, I always have a plan going outside for safety. I know where the kids are going to go. They know where they're going to go. Those expectations are clear. I definitely have a plan. I learned the hard way to have a plan when we come back, because they've got when we've done it face to face, we take the balloon out, so the balloon is there. In the Google Drive, I've given you pictures, so you can put your balloon or your son on a support, and they don't have the problem of playing with the balloons. They've got pictures. But coming back into the classroom, some groups are going to finish before others. And so I want to have something for those kids to do that might finish earlier, to have, when they come back, they dive in on the follow-up activity while the other kids are finishing up. So this can be a management issue if you don't plan ahead. So I've learned that the hard way. I'm sure you've learned that lesson too. So, we collected some artifacts over the years about, what kids think about this. And they have some, the general consensus is they realize how unimportant we are. We think we're big shots. We're on the Earth and we rule the solar system. Well, those ideas were okay in the 1500s. Now we know better. And this is a good way to find that out. Alan, do you want to go back to the slide on AUs?
Sure.
Okay, let's talk about AUs.
Yeah, so this was just an optional activity at the end. If there's extra time after they're done outside and they want to come inside and work on this. So this was the last column of that one data table. And this part of the activity is about understanding and appreciating different units of measure. And so the AU is the distance between the Earth and the Sun. And so it's a convenient measurement for the orbital radii of all the planets, because instead of thousands and thousands of meters or kilometers, it's the Earth is 1, and Venus is maybe I think it's about 0.7. Neptune might be around 30, and so it's just a convenient measurement system. And there are other convenient measurement systems in astronomy as well, like using light years and parsecs on more of a galactic scale. And so this is just a little extra activity that they can do to kind of convert the solar system distances into a more convenient unit of measure that they use to measure these distances in astronomy.
Using the AUs, looking at the distance between the planets and AUs, kind of drives home the point that, for example, as Alan mentioned, Neptune is 30 AUs. So it's really out there. Earth, Venus, Mercury, Mars are about 1 AU apart. The distance is very similar. When you get out to the gaseous, the giant planets, and they're really immense. So this may not be appropriate for 5th and 6th graders. I don't know if your students might be interested in the math. It's simple math. It's just a comparison, just a different way to measure. Alan, do you want to go to the last slide? Okay, I'm going to wrap it up here, and thank you for your patience. I know we got off to a rough start. If you want to contact either Alan or me, here is our contact information. And again, you don't need to write this down because it'll be there for you to see later. We did put a link here for our YouTube channel. We're putting up activities, lessons that we've done. There are some there already. Some are literally 3rd and 4th grade level. Others are more high school level. So there's an assortment there for a rather broad group of ages and grades. We also we tweet once in a while of upcoming things and things we've done. So if you'd like to follow us on Facebook, not Facebook, on YouTube, we'd love to have your subscription. Alan, you want to quit sharing? Does it? We can see each other now. Does anybody have any questions? Anything you want to add? Do you see any challenges? So before we wrap up, talk to us. Is this something that is feasible, not feasible? Is it going to be difficult? What do you think?
Oh, I see a comment, Dave. That's a good point to make. It's as a high school teacher, I would plan to do all the math and then the outside stuff the next day. And, we usually have, 2 to 3 hours, I think, during SMAP to do this. And so it's definitely something that would be good to do over multiple days.
What about, do you have any students for whom this would be a problem? So for example, in addition to, maybe some behavioral issues, what about sensitivity to gluten? Play-Doh has gluten in it. Is that a problem for you? Is that something you can overcome?
I was going to make a smart but comment that we're all going to have so many darn gloves left over from probably stocking up for COVID that you can just provide your gluten student with a pair of gloves.
Yeah, Dave, here's another question in chat. Says, would you suggest working with conversions with various units like AU, kilometers, millimeters, centimeters for 7th graders?
I think, sure. So, millimeters, centimeters, meters. So they have a meter stick. They're going to measure the length of the string. They have, the string around them. So some people would say, why do you do everything and why do you do inches around the balloon and then do millimeters on the planets? It's a matter of convenience. And I think that's you could do centimeters around the balloon. And, in retrospect, maybe that would be a better way to go, except when we go to the Exploratorium website, centimeters isn't an option. It's inches and millimeters. So just to be able to do that, we measure in inches. But I think to, even to convert from inches to centimeters, I think is a doable thing in 7th grade. AUs might be a little bit less relevant, but sure, within the metric system, yeah, those conversions are fine, and yes, I would do them. Before you go, I said I would show you how we do it at Purdue, and Alan had a couple of photos. Here's it. When we do this at Purdue, and I kind of go all out sometimes, but I made this little stand. This could be a shop project. And so when the kids make their planets, I just got some little, plastic shot glasses. I glued a dowel on the bottom. Of course, we don't tell the kids what these are for. They're just little glasses. But this is just a stand. So when they go outside, they can take their planets with them. So when we do this at Purdue, I actually, and there's a drawing of this in the Google Drive. I made these stands, and it's just they're PVC. Again, this would be a shop project for your high school kids or a parent. A parent would probably love to do this. They come apart so they can store easily. There's a plan for this in the drive that's just, PVC pipe. I squirted a little insulation in here so that before I put the caps on, I filled it with sand, because now otherwise they tip over every time the wind blows. The stock has a little binder clip on it. And so when we go outside, the kids will each group will have 8 of these. We don't do Pluto. It's just too far. Then we'll put the picture on the stand, and they know which planet it is. And then, just for effect, the kids will take the little cup with the planet and put it in the top. Now, that's no big deal. It's just a little detail that I think, well, if they are looking at, and we take the balloon with us. So we put the balloon in the clip. And if you're 30 feet from the balloon and you've got mercury and you see the balloon and you see this little less than a millimeter piece of Play-Doh, I think that kind of makes an impact. But that's how we do it at Purdue. We sent some of you sticks, and these are okay. They probably aren't going to last more than a couple of years, but you need dirt to stick these into. This thing you can do on pavement, and that might be an advantage. But so I would just tape the picture to the stick and boom, stick it in the ground. I've had students who did this at home use 2-liter bottles filled with water, different colors if you want to go all out, so that you can then put the 2-liter bottles, down wherever you are, the play field. So, and then they put the picture on the 2-liter bottle. So if you are trying to think of ways you can do this, I might have suggestions. I also am really interested if you have suggestions. What works for you that might work for someone else? I would love to share those ideas. So that's why I would like to create a little community. I think in the materials I sent you, I included a Google form for teachers for SMAP, Saturday Morning Astrophysics. Sign up with the group, and then you'll get notifications every time. We're doing something this Saturday morning at 11 o'clock Eastern time. It's going to be on the lives of stars. So I can email me, you can email me and I'll send you details. Sign up for SMAP for teachers for SMAP. I'll give you the details. It's a great lesson. In fact, we're going to do it on a little smaller scale, but what kids are going to make is what we call an HR diagram. So I can give you access to the Google Drive with all the information. So we're going to look at the life cycles of stars.
Thank you all for coming.
Yes, thank you. We'll end the meeting and let you get on your way. And thank you for your patience.